This is question 37 from the GATE 2020 Ec paper, where we are asked to perform small signal analysis for the following circuit and find the Norton equivalent resistance looking into the source of the transistor. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic. So let us solve this problem. In this problem, we are asked to consider GM and RDS, that is the drain to source resistance and the transconductance of the MOSFET in its small signal model. And we are asked to look into the source and find out what the Norton equivalent resistance is. Of course, this is also small signal, right? We will need to know what it is in terms of the resistance R, GM and RDS. So to find the Norton equivalent resistance, first we convert it into small signal model, where of course we short the DC source, and if there were any capacitors we would short them too, and if there were any inductors we would open them for the small signal model. And then we apply a test voltage, right, at the source and find out what the test current is. The objective is that R equivalent will be equal to V test by I test. So replacing the MOS transistor with the following equivalent small signal model. This is the small signal model with GM and RDS, where VGS is the small signal gate to source voltage, right? And GM VGS is the small signal drain current component due to the gate to source voltage, and VDS, that is VDS divided by RDS, will be the small signal drain to source current component due to the RDS resistance. So now Vs is equal to V test, Vg is equal to 0. So VGS is Vg minus Vs, that is 0 minus V test, which is minus V test. Of course, now if we apply nodal analysis at the source node, right? So at the source node, we have GM VGS coming in, we have VDS by RDS coming in, and we have I test also coming in. So we would have to have VDS, which is, of course, we can also write it as the current going in that direction. So the current going out will be equal to the sum of the currents going in. So the current going out, that is through the RDS, is V test minus, since I test is coming in, I test would have to go out this way, right? V test minus I test into R, right? Because the voltage drop here will be I test into R, right? Divided by RDS, right? That is this current, and that is of course equal to the sum of these two currents, because we are doing nodal analysis at the source. So this is equal to GM VGS plus, of course, I test is coming in, right? And this is the expression that we have over here. So solving this expression, this equation further, and taking terms on the appropriate side, taking common V test on LHS and I test on RHS, we will find that V test by I test, which is the Norton equivalent resistance and incidentally the output resistance of this amplifier, will be the following equation: RDS plus R divided by 1 plus GM RDS. Thus the correct option is B.